Hello guys, this is Paul McWhorter from TopTechBoy.com, and we're here today to learn how to pass data from your Arduino to Python running on your desktop computer. A lot of reasons you would want to do this. We love the Arduino because it's very easy to interact with sensors and actuators in the real world with the Arduino, but very quickly you're going to reach the point that you need more horsepower in analyzing that data. Best way to do it, take the data on Arduino, pass it to Python, and then once you're in Python, you can live graph data, you can create 3D visualizations of the data, you can do very sophisticated data analysis, you can send it other places. Once you get the data into Python, the sky's the limit. So what we're going to talk about today is how to pass that data. Now, specifically in this series of tutorials for you guys that are playing along at home, what we are doing is we are building a 9-axis inertial measurement system based on the Adafruit B&O 055 9-axis sensor connected to an Arduino Nano. Now, what we're going to show you today is how to take that data that is being taken by the Nano and to pass it to Python. Now, if you're not playing along with this particular project, it's okay. What I'm going to show you is something that will work for just about any project that you're going to do. Now, I have to tell you that I am not trying to show you the most efficient way of doing this. I'm not trying to show you the fastest way of doing it. I'm not trying to show you the smartest way to do it. I'm trying to show you the simplest way that will work for almost anything and is very easy to understand. And I will just kind of give you a real quick overview of the way it works. There's kind of two parts to the problem. On the Arduino side, you've got to collect the data and then you've got to pass it, okay? On the Python side, you've got to catch it. So there's two parts to today's lesson. First part is going to be how to pass the data from the Arduino. The second part is on Python, how to catch it. So let's just jump right in. Oh, and then, so I'm going to show you just real simple. We're going to make up data, show you how to pass it. So if you're just here kind of like a drive-by shooter, you're just here to learn how to do this, you'll learn it. For you guys that are playing along with this project, then I will show you for this data that we're collecting off the sensor, collecting off the sensor, I'll show you how to pass that data. The data that we ended up with, I believe that data we ended up with in lesson number 10. I'll show you how to pass that to Python. So this will work for either people that are going through the series or people that just want to know how to do it. But in either case, I need you to not forget your iced coffee. And I will need you to call up your Arduino IDE. And I think this probably looks like a pretty good view here. Start with the blank program. And what we need to do is I want to show you that we can send dynamic data and we can send kind of packets of data or different channels. So I'm going to create 3 channels, an X variable, a Y variable, and a Z variable. In the real world, this might be temperature, pressure, and humidity or something like that. But we're just going to say I'm going to have an int that I'm going to call X, and I'll initialize it to 0. I'm going to have an int that I call Y, and I'm going to initialize it to 0. And I'm going to have an int that I'm going to call Z, and you guessed it, I'm going to initialize it to 0. Now, we have our 3 variables. Now, the way you send data to Python, you send it over the COM port. So if I'm going to send data over the COM port, I need to turn it on. How do we do that? With our old friend serial.begin. And while we seem to be in the habit of using 9600, when I'm getting data into Python, I don't want to fool around. I want to get it there quickly, so I will use 115.200. So now my serial port is turned on, being mindful not to forget my semicolon as I do so many different times. Okay, now we want the data changing. So let's just say that X is equal to X plus 1. Let's say that Y is equal to Y plus 2. And then, not U, Y is equal to Y plus 2. And then we're going to have Z is equal to Z plus 4. So we can kind of see the data changing. All right, now this is the simple bottom line on the Arduino side. the way you send the data is kind of like we would do a print X, and then we need a delimiter. So we'll do print X and then print the character, the comma, and then we'll print Y, and then we will print the character, comma, and then we will print Z. But since Z is the last number in a packet, we'll do a print LN. So it's sort of like print number, print comma, print number, print comma, print line number, and then that's a packet that we can pull in all at once on the Python side. And so let's come down here and let's just jump right in. And so I will say serial.print. And what do I want to print? I want to print my first number, which is X. And then I got to put in that delimiter. So I want to print, and it's got to be the string, right? It's got to be the string. So it will be the string, comma, and then serial.print. And what do I want to print now? I want to print the variable Y. And now I got to put in another delimiter, serial.print, put in another comma. Okay. And now, don't forget the semicolon. Now we got to bring it home, right? We got to put in that Z. Okay, we have to put in that Z. So I'm going to say serial.print ln. Okay, because this is the last number, I've got to tell it this is the end. So I do it with a serial.print ln. And now I do Z with a print ln. Okay, let's download this. And two things to make note of. Remember, 115,200 on the baud rate, and we have to make note of what COM port we are on. I come down here under Tools and I look, and for me I'm on COM 5. You'll be on something different, but make note what your COM port is. And now let's download. Oh, denied. Oh, pint. Did you guys catch that? Print. Okay, hopefully you didn't dumbly copy my mistake. Okay, boom. This is going to work. Okay, now let's just pop open the serial monitor and see if it makes sense what we are seeing. Okay. Oh, and that's going by so fast. You know, guys, you can send things faster than you can really deal with it. We should have put a little bit of a delay in here. And so I'm going to say delay about 100 just so that I am not cramming the data faster than what it is easy to deal with. So let's download this again. And we will pop open the serial monitor. Okay, much better. You see X is counting by 1, Y is counting by 2, Z is counting by 4. This is not surprising, right? But this is just making sure before we jump in and try to do things in Python, let's make sure things are behaving as we would expect on the Arduino side. Okay, we are ready to go now and start writing on the Python side. Couple of things about Python. Okay, if you're a Python expert, you already know how to, install things and all that sort of stuff. But if you're new to Python, make sure that you install Python the way I showed you in lesson number 11, because I showed you how to install Python in a way that our helper program pip will be there and will work, and also your paths are set up so it won't get lost. Okay, if you just have an old version of Python and you don't know what you're doing, go back to lesson number 11 and install it like I show you. And also, if you want that pip, you've got to install like 3 point something. The 2 point something doesn't have pip, and then pip itself can be kind of hard to install. So bottom line is, do what I did in lesson number 11, and then things today in lesson number 12 will work. Now, there is one thing that you are going to need. Okay, there is one thing that you are going to need that did not come with Python. So in Windows, I need you to open up a command line. If you go to the bottom left of your screen and in your little search bar, you type CMD, you will see that this command prompt app comes up. You need to open your Windows command prompt, which I have just done. Okay, now since you followed the instructions in lesson 11, pip should already work for you. And what I need you to do is do a pip install pip install py PYSERIAL pip install py serial. Okay, it's collecting it, it's installing, successfully installed. Boom, we should have Pi serial. Now, what does Pi serial do? Remember, we are throwing data down that COM port on the Arduino side, this PySerial is a library that will allow Python to go out and catch the data that is coming down that COM port. All right, so that is installed. I can close that now. And I think we are ready to open up Python. So again, I'll go to the lower left of my screen and I will search on IDLE. That's my integrated development environment for Python. And you can see here I have idle for Python 3.7. For me, it's 64-bit. For you, it might be 32-bit. If you have a 32-bit machine, that is fine. So let's open that up, and boom. Another thing that annoys me is it opens up a shell instead of a program window, but that's okay. While we're in the shell, you can kind of just type in individual lines of code for Python and it will execute them one at a time. So I want to just make sure that that PySerial installed. So I'm just going to type in a command, import serial, and the only reason that I'm doing this is just to see if it installed. Okay, boom, I didn't get an error, which means when I give the command, it goes out and finds it. Forget that now, we know that it works. All right, so now what I want to do is I want to open up a window to create a program. So I come to File and I say New File. Okay, this is the environment now that I will write my program. And let's see, I think you can see that. I think that a person like you should be able to see that. I'm always try to be mindful of my fonts, that I'm doing something that would be easy for you to do, easy for you to see. Okay, so we're now going to write a program that will go out and grab that data that is coming off of the COM port. So first thing, since I'm going to be interacting with the COM port, I need to import serial. I find it a little awkward that the library is called PySerial, but then we import serial, but that's just the way it is. When we set up that COM port, we need to put a delay in there. Another annoying thing about Python is if you want to delay, you have to import the time library. So now we will be able to delay. Okay, now I want to create an object that I associate with that COM port. Okay, and then if I want to interact with the COM port, I interact with the object. So what I'm going to call the object, I could call it whatever I wanted to, but I'm going to call it Arduino data. Okay, that's the object. What's it equal to? Serial, that's that serial library, dot S-E-R-I-E-L. So notice, be mindful of the uppercase, lowercase. So serial, all lowercase, dot serial with an uppercase S. And now I have to tell it what COM port am I going to work with. Well, I showed you on mine it was COM 5. On yours, it's going to be different, but whatever COM port that Arduino is on, for me it's COM 5. What was our baud rate? 115/200. And so now my COM port here has to match what the Arduino is, and the baud rate has to match. Now I've got an object with which I can interact to get the data. Now when I set that up, I want to give it a little delay, so I'm going to do a time.sleep, and this is in units of seconds. So I'm just going to wait a second to make sure that that serial port has a chance to get all set up nicely. Okay, now I want a while loop. I want a while loop that loops forever, so I will say while 1 equal 1. When does 1 equal 1? 1 always equals 1, so this is kind of like your void loop in Arduino. It's just going to loop forever. And then remember, in Python, we keep track of our clauses or our whiles or our ifs based on indentation. So after it sees that colon and I hit a carriage return or an enter, what you notice is it indents. Everywhere in this while loop, you've got to keep that indentation straight. Okay, so now what do I want to do? Well, I want to wait until there's data on that COM port. So I need another while loop. So while Arduino data dot in waiting equal 0. And then another colon. So what is this saying? I'm going to go out, I'm going to look at the serial data, and I'm going to sit there and just loop until there's data there. So if there's no data there, the in waiting data equal 0, what do I want to do? Absolutely nothing. I just say pass. And so what this little loop does is it just hangs until there's data there. All right. Then once there's data there, I pop out of that while loop and I come back indented for the things that are going to be inside of this while loop. And what do I want to do? There's data there. If I get to this point in the program, there's data there. What do I want to do? I want to read it. So I need to create a variable. I think I will call it data packet. You could call it whatever you wanted, but I think data packet makes sense because I'm going to read that whole thing from the first character to the first line ending, which is that print ln. I'm going to get that first data packet. Data packet is equal to, what's my object? Arduino data. And then what do I want to do? I want to dot read line. That will read everything until that first return or that first line ending. So now I have data packet. You know what? I think at this point I should have a data packet. So let's just print it and see if this thing is going to work. So I'm going to print data packet. Okay. And so now let's run module. Okay. Source must be saved. This annoys me. I got to figure out something to save. So I will just call it catch data and then overwrite what's already there. Yes. Okay. So now it is starting. The shell comes back and boom, look at that. Boom. In Python, I am grabbing that data that is coming from Arduino. Couple of little things to notice. It brings it in as one big string. And then just to be annoying, it decides to put this B single quote in front of the string that you sent. Now also this /r/n is kind of like the carriage return. That could be associated with that print ln. That could be the thing that told it was the end of the line. So I'm not going to blame Python for that. That's probably what we sent from Arduino. But we need to get rid of this annoying B, okay, this B colon. And there is a little command that will do that for you. Let me kill this. And we come over here, and so before we print data, let's strip that little annoying thing off. So I'm going to say data packet is equal to the string value of data packet, only I'm going to give it a format that I want. I want the format UTF-8. What is that format? That is the format that doesn't have that annoying B on it. So now if I print data packet, if I'm careful to make sure that I do the capitalization, the uppercase, lowercase correctly, this should print it out and shouldn't have that B now. So let's run module. Okay. Boom. Do you see that? Okay. X is counting by 1, Y is counting by 2, and Z is counting by 4. That is most excellent. So I'm getting that data in there. Okay. Now that looks good, but what you got to still realize is that's a big long string. And if we're passing this over, we're kind of going to probably want numbers. Okay, we're probably going to want numbers and not a string. And so I need to take this string, which is number, comma, number, comma, number, and I need to split it into an array of kind of like the first number, the second number, and the third number. So I need to create an array, and what will we call that array? Well, I'm going to call it the split packet. Okay, so it's going to take data packet, and instead of being one string, it's going to split it into 3 strings. And so I'm going to say split packet, which is going to be an array, is going to be equal to data packet, okay, dot split. So this is saying take data packet, split it into its individual numbers, and put it into an array called split packet. And if I'm going to split it, I got to tell it what character to split it on. Now, what was our delimiter? What was our delimiter? It was the comma. So I can put a single quote, and then I can put a comma, and then I can put a single quote, and that should split data packet at the comma, and then it should put the values in the array split packet. Okay. Now, split packet should have those 3 numbers that I want of X, Y, and Z. So now I can just come in and say X is equal to split packet. This is an array, so I got to give it an index. X was the first one. What's the number that goes with the first one? It is the 0th term. So it will be the 0th term in the list. We count from 0 in programming many times. Y is equal to that split packet, and that will be the 1th term. And then Z is equal to split packet 2, which is the 3rd term. All right, if I just did this, I would end up with 3 things, X, Y, and Z, but they would be strings, because if I take a string and I split it, I'm going to end up with strings. And I don't want the string 6 or the string 45. I want the number 6 or the number 45. So what I need to do is I need to float these when I do this. So this will convert the strings to a float. Okay, so that I will float, I will convert, when I put them in X, I will convert them to floats. And that way I'm dealing with numbers. Because if you try to do math with strings, it gets ugly. Sometimes it'll actually do it and you get really crazy results and you could kind of start driving yourself insane. Okay, now I have X, Y, and Z. Let's print them out nicely formatted. So I'm going to say print and print. First thing I want to do is print a label, so I'm going to have the label X equals, and then a comma, and then the value X. And then the label, I need to put space before the Y so that things aren't jammed together. Y equal, and then print Y, and then print the label space Z equal, and then comma, and then print Z. I think this should work. The neat thing is now I have a number I can work with X, a number I can work with Y, a number I can work with Z. So I passed the data, I caught it, I parsed it, and now I'm going to see if I can print it. Let's hope this works. Run module. Okay. Hey, this looks promising. Boom! Look at that. Do you see that? Look at that. And they're numbers, they're not strings. X equals counting by 1, Y equal counting by 2, Z equal counting by 4. So if you came here to learn how to pass data from Python to, from Arduino to Python, mission accomplished, okay? But if you came here to move forward on our little 9-axis inertial measurement system, let's go ahead now and let's do a little bit more. So instead of just passing these made up numbers, let's pass that data that we ended up with in lesson number 10. And so what I need you to do is I need you to go to, if you have your code from lesson number 10, good for you. But I know most of you guys, and so you probably don't have your code. So what I need you to do is go to the most excellent www.toptechboy.com, and I need you to search on 9-axis IMU lesson 10. And you cannot see that, can you? I'm sitting here ridiculing you. Okay, where is the here it is. Okay, so I need you to go to www.toptechboy.com. I need you to search on 9-axis IMU lesson 10. Okay, come to this lesson and go down and you can grab the code here, Control C, to copy the code that we ended up with in lesson number 10. All right, now we are going to come back to Arduino. Okay, and this was our Arduino window, so I'm just going to do a Control A to select everything. That's Control A to select everything. Control V to paste our old program. Right now we pasted our old program, and remember what that old program did was it was coming up with approximations for roll, pitch, and yaw. And then we would do a better approximation and a better approximation and a better approximation. So if we download this, this is going to run because we ran this before. Oh, okay, very good, very good. Okay, I was getting cocky, right? I was getting cocky. Remember, you can only touch that COM port with one thing at a time. And I do believe that we left this Python program running. And because we left this Python program running, it has locked up that COM port. So we got to kill it. And then we come back over here and now we download it. I'm very confident this time. Very, very confident. Okay. Ready? Waiting for it. It's kind of slow to download. Okay. Boom. Got it. Now let's just pop open our serial monitor, and you see that we have all of this data, all these different things that you know from the earlier lessons what those things mean. Okay, but now that we're going over to Python, I don't need all those intermediate results. Remember, we had like a tilt directly from the accelerometer that was a pretty good tilt, but it was subject to vibration. So we had all those intermediate ones, and I don't want those. Now I do want the calibration data, so I want the Excel, the gyro, the MG, and the system. Those were our calibration numbers. So I'm going to, or the status of our calibration. So I'm going to keep those, but everything before that, I am going to eliminate. So this is the calibration status of accelerometer, of gyro, of magnetometer, and system. And now I start getting a lot of those intermediate calculations for roll, pitch, and yaw. And I'm still calculating them, but I'm just not going to print them because it's just going to slow me down. I'm going to come down to this point. So system calibration, a comma, and now theta is approximation of pitch, phi is approximation of roll, and then psi is an approximation of yaw. So I'm just going to send those 7 numbers. So let's download it, and we're going to check it because, man, make sure before you go, you know what I see students do? They write the Arduino code, then they go to Python and write hundreds of lines of code, and then it doesn't work. Before you go to Python, make sure that Arduino is working like you expected it to. So we will pop open our serial monitor. Okay. And now we have 1, 2, 3, 4, 5, 6, 7 channels of data. I see commas between them all. So this looks good, all right? Because it looks good, I am now going to go over, and I am going to go over to my my Python program. Because remember, this Python program is already doing almost everything that we want. So we import serial, we import time, we open the COM5 port, we rest for a second, then we have the loop, now we read data packet. That all should be the same. Okay, then we strip the nonsense off the data packet. That should be the same. And now split packet should be the same, but now we're going to have like 7 values here. So I'm just going to take this and I'm going to just paste it, and then I can come in and fix things. Okay. But that first number was like the accelerometer cal. The second number that we sent was the gyro cal, so we'll call it G cal. And then the third number was the magnetometer cal, the status. I still need one more, right? Because there were 7 and I have 6. So I need 7 of these things because there's 7 pieces of data. So accelerometer calibration status, gyro calibration, magnetometer calibration, and then this would be the system calibration. And then this, I believe, we sent was pitch, and then we sent roll, and then we sent yaw. All approximations suitable for impressing your girlfriend, but not to be put on fighter aircraft or drones or flying blenders. Okay, so the A calibration would be the 0, then 1, 2. This one is the third one. This one is the 4. This is the 5. And this is the 6, and since we started counting at 0, then that's 7 numbers. All right, now we are going to want to print out those 7 numbers, and I need to be mindful to make sure that you can see this. I think you could see everything that I did so far. Okay, so now what we need to do is we need to print all this nonsense out. So I'm going to hopefully, you know what I'm going to do? I am going to go to the full screen view, because otherwise this thing is going to go off of the, it's going to go off the side of the screen so that you can see it. So now we want to do our print. So the first thing that I want to do is I want to print a label. for a cal, okay, a cal, and then I want to print, I guess I should say a cal equals, and then a comma, and then I'm going to print the variable a cal, and then I'm going to print g cal, and then I'm going to print the variable g cal, and then I am going to print, I am still going to run out of space here. No, I'm going to be tiny before this thing is over. So I'm going to print g cal, and then I am going, I should say g cal equals is a good label, g cal equal g cal, and now I'm going to have m cal equal, comma, m cal, and this is going to go on forever, huh? And then you know what I'm going to do? I'm going to do something crazy here. I'm going to float myself up here. I think I'll be less likely to be in your way. Okay, so mcal, and then we're going to print sys scal, comma, scal, and then we are going to print the label roll. The excitement builds as we're going to figure out what happens as I run out of space here. Roll equal, comma, and then we're going to print. I think pitch was first. Pitch equals pitch. I think you can see that, right? And then we're going to print roll, and then comma, or in quote, comma, roll, and then we're going to print the label yaw equal, comma, yaw. Now let's go back and clean this up. Let's use equals everywhere that I didn't use an equal. I think I missed that one. And then let's go up and look at the roll, pitch, and yaw. Yaw was uppercase as well, so I need to make sure that that one is uppercase. Does that make sense? I think it really should. You know, this is terribly annoying because this idle doesn't have a left and right scroll bar at the bottom. So that makes it most annoying. Okay, but I think that looks good. So I do not like to be floating up here at all. I feel very comfortable down in the lower corner. I do not like to be floating up there. So let's see. There we go. All right. So let's see if we can run this crazy program, huh? Being mindful of my window here. I think I need to go back to this other yeah, let's go back to this one. And now let's come over here and run it. Run module. Okay. Tension builds. Boom! We are getting data, man. We are getting data. Okay, I'm going to go back to the, let's see, I'll go back to the full view. And what I'm going to do is I'll try to hold it up here where you can see it. But if I just swing it around, the gyro had already calibrated. The G cal was 3. I swing it around and now the mag cal is 3 and the system cal is also 3. But I need to get the accelerometer calibrated, so I'm going to give it a 45-degree angle. I'm going to give it a 45-degree angle, right? Hold it for like 3 seconds. I'm going to give it the upside down view, upside down with pitch, and then upside down with roll. Okay, and now I've got everything calibrated. Okay, everything is calibrated, and we will come back to this view here. So you can see the data. So what is good is what is very good is that we have everything calibrated, But now I need to change the view a little bit. I need to change the view so that you can actually see the roll, pitch, and yaw, because that's what we care about. So let's see if I can do that. And okay, I'm going to make the font a little bit smaller. So I'm going to come up here and say configure idle so that everything's on one row. I try to keep the font as big as I can so you can see it, but here it is not. Okay. And I think you will do best with this view. All right, so now you can see that we're all calibrated. And so let's see. You guys watch pitch. Are you watching pitch? I bring the nose up and pitch goes up. I bring the nose down, negative. Okay, roll to the right. That looks good. Roll to the left. That looks good. And now as I yaw, let me go back to pointing about north. Okay, pointing about north looks really good. East, south, west. Okay, guys, boom. Do you know how important this is? We are getting numbers, right? We are getting numbers. And I just had one terrible thought. I need to make sure that when we did this, we copied and pasted the floats. And so those really are numbers. Okay, guys, this is really, really exciting. Do you realize how significant this is? We are taking data and we are getting very good approximations for roll, or not very good, we're getting approximations for roll, pitch, and yaw, which are pretty good, probably up to about 45 degrees. And we have done some compensation, right? We did that complementary filter. So we've got numbers that are not really too susceptible to just normal motion and vibration. And we've got the data over to Python. So what I want you guys to do is play around with it and just see if the numbers make sense as you're reading them off of Python. In the next lesson, which will be lesson number 13, we are going to install Visual Python, which is a library that will allow us to do those simulations and those really cool 3D visuals. Okay, guys, I've had fun today. I hope you've had fun. Leave me a comment down below. Let me know if anyone is still playing along at home. We are on lesson number 12. Thousands and thousands of people started. How many people have made it through lesson number 12? Let me know. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.